Hey guys, welcome back. All right, so we're moving through our solving quadratic equations unit, and so far we've done solving quadratic equations by graphing, and again that's kind of nice doing because that's going to work for any quadratic equation. You can always solve it graphically. Okay. Now, let's see. Sometimes a question is going to ask you to solve it algebraically, so you have to do it algebraically. But still, I mean, I'd say solving an equation graphically is a great way to be able to check your work afterwards. If you have a multiple choice question, or if you have like a numerical response type of question, guys, the best way to do is be solving it by graphing. Next, we reviewed some factoring, and then we did solving quadratic equations by factoring. But now, unfortunately, guys, not every quadratic is factorable like that. So sometimes you're going to go, well, you just can't factor it like that. It's just not going to work out properly. Okay, so we're moving towards other techniques of solving ones that are not factorable. So one technique is called solving quadratic equations by completing the square. Now, we completed the square in our last unit where we're converting from standard form of a quadratic function into vertex form of a quadratic function. So we're going to be using that skill to be able to solve these ones. Now really, this is not going to be in my opinion, we not use this technique that often, but we learn this technique so that we can understand something called the quadratic formula, and that's how we prove the quadratic formula is by completing the square. So hopefully that kind of makes sense, guys. But we're going to show you how these ones work here. First, we're going to get into a bit of review. So from Math 10, we had a unit called radicals, or it's called roots and powers, where we had to simplify radicals. Okay, so square root of 8 can be simplified. Okay, so the way we do that is that 8 is equal to 4 times 2. Okay, now the reason why I do that is because like a rule of radicals, if you're multiplying two terms inside of radicals, I can make that square root of 4 times the square root of 2. And I know that the square root of 4 is just equal to 2 root 2. Okay, so this square root of 4 becomes the whole number 2, but then we're still left with the radical of square root of 2 right here. Okay, similarly, so 75 is equal to the square root of 25 times 3. Which is root 25 times root 3, which is 5 root 3. Okay. Now, a strategy for this is you always want to choose, you want to be able to kind of break down and factor the number inside the radical so that one of its factors is a perfect square. Okay, so in this case, 25 is a perfect square. Square root of 25 is 5. So 25 times 3 becomes root 25 times root 3 becomes 5 root 3 like this. Okay. All right, 2 plus root 20 over 2. We're going to see stuff like this in this unit as well, so it's going to see how this works here. So 2 plus root 20 over 3, well, let's do this off the side, but root 20 is 4 times 5, which is 2 root 5. So this is going to be 2 plus 2 root 5 over 2. Now, we're not quite done here, okay, because if I look at the numerator, I have a 2 here and a 2 here. So what I can do is I can factor out a 2 and make this 1 plus root 5 like this over 2. And now since this is factored in the numerator, I can cancel out this 2 with this 2, and I'm left with 1 plus root 5. Okay, so all of these are skills that we're going to need in this lesson over here. Okay, so we need to be able to simplify radicals, and we need to be able to simplify radicals and kind of simplify a rational expression with radicals in there as well. Okay, all right. Example 2. So review completing the square. So the reason why we completed the square in our last unit was to convert standard form, and that was y equals ax squared plus bx plus c into vertex form, which is y equals a x minus p squared plus q. Okay, so here's standard form and here's vertex form. So completing the square did this for us over here. Now, what we did is the strategy for questions like this was, well, we're going to write this plus 2 at the end here, but we need to figure out what do we need to add here in order to complete the square. Now, the way we did that was we go half of 8 was 4, and then 4 squared is 16. Okay, so 16 is going to go with the add. But if I add a 16, I need to subtract a 16 in order to keep this as a balanced equation over here. So now I'm going to group those guys together, and this factors into x plus 4 squared. And negative 16 plus 2 is negative 14. Okay, so that's how first one works. Second one, y equals 4x squared plus 16x. What I'm going to do is I'm going to factor out the 4 out of those two terms. So it becomes 4x squared plus 4x minus 7. So keep the minus 7 by itself. And now I'm going to complete the square on these two terms right here. So I get y equals 4 x squared plus 4x plus half of 4 is 2, 2 squared is 4. Now I added a 4, but I really added 4 times 4 is 16. So I need to subtract a 16 in order to balance here, minus 7. So now this answer is y equals 4 x plus 2 squared. Negative 16 minus 7 is negative 23. Okay, so this is how I complete the square for this guy. Okay. So next thing over here is I'm going to introduce something which we call the square root principle. Okay. First question is, what is square root of 16? The answer to that question, simple enough, is 16. The square root of 16 is 4. So if I ask you what the square root of 16 is 4. Now specifically, guys, it is a positive 4. Okay. So when we talk about something we call the principal root, if I ask you for the square root of a number, it's always going to be a positive number. Okay, but what gets different over here is like this. Okay, so how would I solve this equation? What is and are the solutions to x squared equals 16? So I'm implying that there's more than one solution to this equation over here. Okay, now the way I would solve this is I would square root both sides of the equation. Okay, and that would give me x equals 4. Okay, but and that makes sense because 4 squared equals 16. So 4 is a solution, but there's another solution as well. And the reason is because if I put in a negative 4 over here, negative 4 squared is 16 as well. So we have a rule. Okay. Now, first of all, the square root of 16 is 4. So if anyone asks you this question over here, this is the answer. This is the only answer to the principal, what we call the principal root. But by convention, that's what we use when we're talking about square roots. Okay. So square root of 16 is 4. But when we square root both sides of an equation like this, we always need to take the positive and negative of that solution over here because 4 squared equals 16, but also negative 4 squared equals 16 as well. Okay, so there are two solutions to this guy. Okay, so we're looking at something like this: x minus 4 squared equals 20. Okay, so again, I'm implying there's two solutions here by putting this. But if I square root both sides of the equation, first of all, this is going to get rid of this squared here, and that means x minus 4 equals. But if we square root both sides of an equation, we have to go plus or minus. Okay. Now, what we talked about in a review before, well, what's root 20 equal? Root 20 is 4 times 5. Square root of 4 is 2 root 5, like this. So this is x minus 4 equals plus or minus 2 root 5. And then if I add 4 to both sides, I get x equals 4 plus or minus 2 root 5. So what this means is, I'll put this over here, my first solution, which is something called x1, is going to be 4 plus 2 root 5. And my second solution is going to be x2 equals 4 minus 2 root 5, like this. Okay, so there's two solutions. Now we're going to keep it written like this because this is an exact value solution. Okay. Now sometimes the question may ask you to round your solution, but if it does not ask you guys, if the kind of a standard is that we're always giving exact value solutions. Okay, so we're going to leave it as 4 plus 2 root 5 and then 4 minus 2 root 5, like this. Okay, so example 3, solve. So if I have x plus 2 squared minus 2 equals 0, if I have to solve an equation like this, I'm going to add a 2 to both sides like this. So we get x plus 2 squared equals 2. And then I want to get rid of this squared here. So I'm going to square root both sides of the equation like this. So continue this over here. X plus 2 equals, now remember when we do this, we'll go plus or minus, so when we square root both sides of an equation, we have to put the plus or minus like this. Okay. So now, if I subtract 2 from both sides like this, I get x equals plus or minus 2 minus 2. So that means x1 equals, so plus or minus root 2. So I have root 2 minus 2. My second solution is negative root 2 minus 2. All right, and those are going to be my two solutions for this question over here. Okay, so why I'm showing this question over here is this equation is actually the equivalent form of this equation over here. Okay. Now the other thing is like the way we solve these equations in the last topic, we solve this one by factoring. But if we look at this, if I try to factor this, it's going to be impossible to factor. Okay. I mean, there's no way. The only way I can get to 2 is by going a 2 and a 1, or a negative 2 and a negative 1. It's going to be the same thing. But there's no way I'm going to be able to get a 4x using a 2 and a 1 like this. Okay, so I can't do it. Right. So in other words, factoring is not going to be a way to solve this question over here, because this is an unfactorable quadratic. Okay, so that's not going to work. But the idea is if I can convert this equation into this form, I can solve it the way that I did at this one over here. Okay, so how do you do that? Well, how do you complete the square? X squared plus 4x plus something plus 2 equals 0. Well, half of 4 is 2. 2 squared is 4. Add a 4 and then subtract a 4. Okay, and now this guy factors to x plus 2 squared minus 4 plus 2 is negative 2 equals 0. Okay, so what I've shown here is going from here to this step, and then we can solve this using the square root principle. Okay, so I can just add a 2 to both sides, square root both sides. Don't forget your plus or minus, and you get these two solutions right here. Okay, so I'm not going to do this one again because I just did solve this question up in this part over here. But this is how we'd solve this equation by completing the square. Okay, so x squared minus 6x minus 8 equals 0. So this is going to be another unfactorable quadratic. Okay, so 8. So you can't multiply to make a negative 8 and get a negative 6. So if you go negative 4 and positive 2, it's not going to work. Okay? It's going to give you a negative 2, not a negative 6. Okay, so we need to solve this one by completing the square. So what we learned is x squared minus 6x plus something, and I still have my minus 8 over here, equals 0. Well, I have to add a 9 here, because half of negative 6 is negative 3. Negative 3 squared is 9. If I add a 9, subtract a 9 like this, and now this guy factors to x minus 3 squared. Negative 9 minus 8 is negative 17 equals 0. Add 17 to both sides. Square root both sides. X minus 3 equals plus or minus root 17. Add 3. So x1 is root 17 plus 3. x2 is negative root 17 plus 3. Okay, so we're going to have this as my two solutions for this question over here. Okay, so again, we want to be able to complete the square and then use the square root principle. And the square root principle says that when we square root both sides of an equation, we have to take the plus or minus of that answer like this. All right, same thing, guys. I mean, a very similar question like that, just different numbers. So x squared minus 10x plus 6 equals 0. Can't factor this guy over here as well. So I'm going to complete the square. X squared minus 10x plus something plus 6 equals 0. So this is going to be a 25, because half of negative 10 is negative 5, squared is 25, and then we go minus 25 like this. Factor this bad boy, and we get x minus 5 squared. Negative 25 plus 6 is negative 19 equals 0. I'm going to add a 19 to both sides. I'm going to square root both sides. X minus 5 equals plus or minus root 19. That means x equals 5 plus or minus root 19. I could have put the plus or minus root 19 plus 5, but it doesn't matter. Same thing, right? So it means x1 is 5 plus root 19, and x2 is 5 minus root 19. All right. Example 6. Same idea. It's going to be, I'm going to say a trickier question to complete the square for. So remember what we do is we want to be able to factor out the 4 out of the first two terms here. So it's going to be 4 x squared minus 8x. Okay, now complete the square inside the brackets. So half of negative 8 is negative 4, squared is 16. All right, so I added 16, but what did I really add? I really added 4 times 16, which is 64. So that means I need to subtract a 64 to balance. So we get 4 x minus 4 squared minus 61 equals 0. Okay, so now square root in this guy over here, we are going to add the 61 to the other side. 4 x minus 4 squared equals 61. And then I'm going to get rid of this 4 over here. So I'm going to divide by 4, like that. So we get x minus 4 squared equals 61 over 4. Square root, and don't forget our plus or minus x minus 4. So I'm going to keep this as square root of 61 is just going to be square root of 61. I can't simplify that one. But the square root of 64 is 2, just 2 like that. Okay, and now I'm going to add 4, and those cancel out. So my solution is x1 equals root 61 over 2 plus 4. x2 is negative root 61 over 2 plus 4. Okay, so again, guys, as we go through the rest of this unit in this course, this is a technique that we're going to learn right now, but it's just we have something we call the quadratic formula that we're going to learn in our next lesson, but we really use this technique in order to prove the quadratic formula and how that works. Okay, I'll see you in the next video and I'll prove the quadratic formula for you.